Hello, everyone, and thank you very much for coming. Welcome to TechSpot. For those who are the first here, TechSpot is a series of technical events, as you can guess. So the first part of this evening is a panel discussion, and let me briefly introduce the setup that we're going here. So our idea was to actually turn this into a series of discussions, because when we were just exchanging experience together within our teams, we realized that it very often happens so that a certain engineer works with just one cloud platform and is not really aware of what's happening on the other platforms. Maybe they play with an alternative platform, let's put it this way, for a pet project. Maybe they observe their colleagues doing something, but the majority of people are just proficient in one platform and have a vague idea of what's happening there. And although between the three major platforms being AWS, Azure, and of course Google, most things are similar, there are still very interesting differences that we hope we're going to highlight today and discuss. So first of all, let's do a bit of an audience study, if you don't mind. Could you please raise your hand who is using AWS at a production capacity? Okay, well, that's an absolute majority. Azure? All right. And Google? I'm sorry to say, you guys, probably the smallest group, but okay. So the panel discussion is going to be structured in the following way. We have chosen three very distinct, very narrow topics. We're going to talk about security and authentication in AWS world. We're going to talk about containerization in Google world, and we'll see the network and connectivity overview as it happens on Azure. After every presentation, there's going to be a bit of time to ask questions. Feel free to invent a nice question, because we have a bit of a swag from Rule. This beautiful red hot marks. So we agreed that the best questions will get the present. So, and we'll also try to ask ourselves the questions. All right.
I'm going to speak about security and authentication on AWS with the following agenda. I'm going to briefly introduce you to principles and identities of AWS. Then I'll tell you how allow certain actions or deny them in AWS using security policies, and then how and why manage multiple accounts. Let's start from the beginning, from principal and identities, and I'll demonstrate you the screenshot from well-known to many of you AWS Management Console. So here's a login screen of Management Console, and here's the main and first entity you're getting familiar with, called root user. So when you're creating an account on AWS, you're actually creating a root user account, and you're logging into it using your email and password, and it's actually the worst way of managing your AWS account. Why? Because this user has full access to all AWS services, cannot be restricted by single account model, and there is better way of manage everything using the principle of least privilege. So to manage your access to AWS, there is a service. Everything in AWS is represented as a service. Service called IAM, Identity and Access Management, and it allows you to manage two primary things: authentication and authorization. So basically ways of logging in into AWS and then granting or restricting permissions for certain principles. Let's briefly talk about principles. So main actors, principles basically can be referred as actors in AWS are IAM user, which is same user as root user. You can log in through email, passwords, or secret and access keys through the API. IAM role, this is not actually the role in English understanding of word role. That's the reason why we have a hat here, actually. I'm going to introduce it a little bit later. Services are actually principles in AWS as well. And if you're using certain systems for managing external users, they also count as principles here. So let's start from IAM users. This is a very simple concept. You can have user created within your account. User can log in user using multiple API programmatic keys or user email and password, and you can create users for whatever way you like. You can create administrator users and then attach policy to it, so administrator can do pretty much anything, or you can create the user for developer, and developer can do access to EC2 instance, or auditor that can read everything, whatever required for audit. Actually, there is a way of managing users using so-called user groups. So you can aggregate your user into groups and assign policies not to specific users, but instead to the groups. Groups cannot be nested, so it's a kind of basic stuff. And you can group your users in whatever way you like, on based on the teams or on a role that they're performing in your organization. And let's talk about role, much more interesting concept. So here's a heads that I introduced a few slides before, and how it actually works. So when user assumes a role, it actually calls service called STS, Security Token Service, to obtain temporal security credentials. And then these temporal security credentials can be used for accessing resources. This is basically like wearing a hat. You're wearing a hat of certain role, and then you can perform actions that are attached to this role using the policy. Pay attention to these are temporary credentials. This is very important because obviously if you're storing your credentials, for example, on your EC2 instance, it's not a secure way of doing it, as in case of leak, you cannot manage it granularly. In case of role, you can just revoke it, and that's pretty much it. Let's talk about way of allowing or denying certain actions inside AWS account, about policies. Policies can be separated into two categories, actually, restriction and granting. Restriction policies are setting maximum permissions within your account. So basically, they can utilize such tool as IAM permission boundaries or AWS organizations service control policies, so-called SCPs. And there are policies that are granting permissions, and they can be separated to identity-based or resource-based policies. How do you grant a permission? As I already mentioned, you can do it on identity-based way. So you're attaching policy to a certain principle, such as user or user group or federated user or role, or you can attach it inline way to resource directly. So it's also allowing to perform certain actions. There are multiple managed by policies that are managed by AWS. A few examples can be visible here, such as administrator access, their self-description basically, Amazon EC2 read-only access, etc. How does this policy looks like? So we're talking about identity-based policy. It's consists of 5 elements. The first one is version-defined structure. Version wasn't changed since 2012, which is long ago, so we're not paying attention to it. Then we have second part called effect. And pay attention, these parts, effect, action, resource, and condition are within a statement, and statement is a JSON array. So all structure is a JSON, and you have multiple. You can have multiple statements within a policy. So effect can be allowed or denied. You're explicitly allowing or denying certain actions. Then the action itself. So you have a prefix of service before it, and then action that is performed within the service. So easy to start or stop instances for this case. Fourth part is resource. You can use wildcards here. Here we have resource of some EC2 instance specified by their ARN, and then most flexible, most important, most viable and crucial part that distinguishing AWS from other clouds is conditions. So basically you can specify almost anything there. You can specify if you want to have conditions specific to tag or to date or to almost anything you like, and this makes these policies are truly flexible. So this policy can be assigned to groups, users, roles, and then these roles can be assumed by resources or users. So policies are driving everything within AWS IAM. How these policies are evaluated? Very simple. So there are 2 statements. allow and deny, and then if something is explicitly denied, then answer is deny. If certain action is allowed, then answer is allow. And if it's not allowed or denied, it's implicit denied. So everything that's not allowed is implicitly denied. A few notes about resource-based policy. Structure actually same to identity-based policy, but you can see a principle here in the middle. I'll try to visualize it in a way that this tablet allows me. So yeah, we have a principle here where we get a broken line here. Principle can be user group, user itself, federated user role, whatever. And these policies has a principle because of their inline nature. Moving forward to permission boundaries, this is type of restriction policies. So you can specify certain actions that are allowed within your account, and then these actions are going to be evaluated together with your identity-based policy. So you're basically setting up maximum permissions, and only on an intersection of policies and permission boundaries, you can have actions that are allowed, so limited actions that are allowed. This is your guardrail. So if you're allowing your users to create IAM policies, for example, and assign them to your principals, it's better to set up permission boundaries so you will have better security within your organization. We have really a lot of information here, a lot of principle, a lot of policies. Why everything is important? Because it actually allows us to follow the principle called defense in depth. This looks like this. So you can have, for example, for accessing documents in your S3 bucket, S3 bucket it's object storage in AWS, to access them in some kind of sophisticated system, you can have user, they're assuming roles, and users are allowed to assume roles based on IAM policy, and roles also have policy. And then you have two resource policies for your S3 VPC endpoint used to access S3 bucket, and then bucket policy specified on a bucket level. And only if everywhere you have allow statement and don't have deny statement, you can access these documents. So this is actually helps you to ensure that if you want to do something, you have to specify it on multiple levels. It will be less accidents. How we're managing multiple accounts in AWS and why we're doing it in general. So why we want to have multiple accounts? So first of all, it's a common practice to have multiple accounts for different teams. Also, if you're following certain security or compliance requirements, you also might be required to have separate accounts for financial or medical information. Also, you might want to have separate billing for your teams or for different branches of your organization. And your business process also might require to use multiple accounts. And in the end, you might have inheritance of your company merged with other company, and then you have their AWS account. It's very simple. How it's managed with our service called AWS organization? And it's a kind of naive way. So you have multiple accounts. You have account number one, number two. You want to have your users, your developer, for example, or your manager of the account, and then you have to create these users, assign credentials to them. Then you have to define policies in both accounts, and then you have to assign policies to users. You basically have to do a lot of redundant work within each account. And you're also not going to have some kind of concatenated billing advantages related to batch discount, etc. So better way of doing it is using a service called AWS organization. What is the service all about? So it allows you to have your organization separated to multiple organizational units. They can be nested. It's not like user groups in IAM. And your organizational units can be related with service control policy that set up maximum permissions for a certain organizational unit. And you also have management account. You can have enable to disable feature of consolidated billing there, but it's totally up to you. And this is more preferable way of managing. You can define policy, user, or whatever resource you might want to have in your account, and then spread it through your organizational tree. How this policies, service control policies that I mentioned are evaluated, basically same way as IAM permission boundaries. So they're not allowing anything, but instead specifying maximal permissions that can be used within organization. Only on the intersection of organizational SCP and identity-based permissions are real allowed actions. This is also part of the concept called layered defense, similar to defense in depth concept. So if you're requesting AWS account using any interface, such as command line interface, web interface, console, not important, trying to obtain access to something, it has to be allowed by SCP permission boundary, if there are any, and then by identity-based policy. If on any steps there is a failure, you're not going to have access to it. So this was brief representation of AWS security, account security. Let's summarize everything. So first of all, use principle of least privilege. It's enforced by AWS by default, but still it's better to use it. Use all the constructs provided by cloud. So I mentioned a lot of them here. Policies, roles assumptions, SCPs, permission boundaries. I also have not mentioned, but it was on slides that IAM allows you to track actions that were performed by user. By service called CloudTrail. Also, you can use a guard duty, and there are many of them. If you're utilizing all of them, you're most likely to be secure. And utilize your layer defense. It's easy with AWS and defense in depth approach. And most important thing, stay safe. Any questions?
Thank you, Kiryl. Before the audience comes up with any question, I can ask you a question if you don't mind.
Go for it.
Sure. So, not sure how it's going to be relevant, but I'm sorry, one more question to audience. How many guys of you use external identities? Oh, okay.
Nice. We have one person.
So imagine we have an external identity provider, I don't know, Okta or something like that. Are there any better or preferred ways of how you would map permissions from a federated user onto the AWS account? Is it better to use assume roles or use user groups or whatever, just from your experience?
So first of all, I just said that federated user is one of the principles of AWS. So you're basically utilizing the same approach as for all other principles, such as IAM users. You can utilize roles for it. It's the best way to do it. And your policy, for example, can specify on the roles your user can assume. You can work only under a specific role because it's easier to manage. But in general, if you're following all the practices I described on the previous slide, it will be secure for you. And I also have not managed, but it's important thing. Role can be assumed cross account. So if your federated user is a developer, for example, and you're allowing developer, obviously, according to the role, access to developer account, to staging, let's say, we call it dev staging often, and you want this developer to able to provide support on production account, you can allow them to assume read-only role in production account. This is a very powerful feature of AWS.
Okay, thank you. So, any questions from the audience?
There is a possibility of assigning a role, IAM role, probably your mic was disabled. There is a possibility to assign IAM role to EC2 instance, and then based on a policy attached to this role, an application within EC2 instance can access resources according to the policy. And important thing here is that EC2 instance obviously works within AWS account, AWS ecosystem, and you do not have to provide secret and access key to this instance explicitly. So you can just assign a role to this instance and then access all the resources that are allowed to be accessed using this role. If you're asking about if you're allowed to access IAM programmatically as part of your business logic to create certain user groups, for example, of course it's possible. It's actually the way such infrastructure as code utilities are working. So all of them are accessing AWS API, and then some of them are accessing IAM, and then it can be part of your business logic. Yeah, for sure.
Thank you for a question.
Any of them?
Okay, can I ask you a
question?
For
sure.
Yeah, sure. This is more related to Kubernetes, but I wish I can ask that. Can you please explain, just maybe in few words, how the IAM is connected to managed Kubernetes service in AWS, which is EKS1?
Yeah. So first of all, let's understand that IAM defines access to AWS resources. It does not define any access to nodes, pods, services, or any other Kubernetes constructs. And there is a technique that allows you to have a service linked role assigned or assumed by node group or cluster, and then based on a place where you're calling AWS API, so node group or cluster, you can have access to specific AWS resources. For example, secret manager or systems manager parameter config, or S3, probably you want to have access to bucket to create something, or EC2 load balancing. It's not part of EC2, but it's defined under EC2 resource family. So I'll try to recap what you said. So you have organization, and your organization uses S3 account, and then you have some kind of analytical pipeline that basically dumps data into S3, and then you want to share this data with your customer, and your customer currently uses pre-signed URLs generated by your company to access this data, and you want to have something more flexible. So I actually don't have a really flexible way of going through slide, only like next and previous. So I'll try to recap what I demonstrated verbally. So first of all, you're allowed to have a resource-based policy assigned to S3 bucket, and then you have a principal there, and principal can be any account, not only your account. So you can share the whole bucket. But obviously, this is not the thing that you want. Better way will be to create a role, allow assumption of this role to AWS account of your customer, and then assign policy to this role that will allow to access to certain key within your S3 bucket. So for example, key can be called analytical workload or something like this, and then / and asterisk sign, so wildcard. And then when your customer needs to receive data from your analytical workload, you can assume a role in your account, go to the S3 bucket, receive by policy, allow on access of these files and download them. And remember, it's always better to use layer defense there. So if you have S3 VPC endpoint, you can allow your customers to connect to it and then do the thing that I just described. Unfortunately, this is a disadvantage of having a root user. And in general, when you're using AWS organizations, you probably are not required to do anything as a root user. But it's always nice to have so-called break glass to access this account if something went wrong. And unfortunately, you already managed the best way to secure this. And it's kind of painful. I can agree with you.
Okay. Veronica is gonna talk us through containers running Google Clouds, different flavors, different ways. So on to you.
Okay, hello everyone. Nice to see you here. And I'm also happy to be there and share my knowledge with you. Unfortunately, it looks like it's not working. Yeah, thank you. I will try to look at the iPad and the board and you guys to make like eye contact. So let's start. I'm going to talk about containers on Google Cloud. And you know what? Container is IT. The most popular technology, I might say, and from my DevOps world, many people already work with them or wish to try. And there are many variants how you can set up it in Google Cloud, and let's see what I can tell you. Our agenda for today is discover the Google Kubernetes engine that I will be talking most of the time about that because I'm mostly experienced working with it. Also, we will cover Google Cloud Run and Google Anthos, which is also called GKE Enterprise. Why we're talking about Kubernetes? Before I continue, I would like to ask audience, please raise your hands who already used to work with Kubernetes. Yeah, great. I see a lot of people, most everyone. So you can see statistic here. I will not repeat the numbers, but as far as you can see, most of the IT leaders company already use Kubernetes. And this is the key platform for moving to public cloud, according to Red Hat report of 2022. And according to Cloud Native Computing Foundation, the report that Kubernetes is the most spread container orchestration tool. I believe there are other, but this is the most widely used. And it was really interesting fact for me that the adoption rate of Google Cloud is 32%. Actually, I have experience mostly working in AWS, and from my perspective, I thought that the AWS is really the huge and the most widely used one. But you see, things get changed, and it looks like Google Cloud took the leader position, and the rest of the percentage is spread between AWS, Azure, Rancher, and some OpenShift. So let's go next. Let's see what we can explain about Google Kubernetes Engine. This is managed Kubernetes service for containers that is running on Google Cloud infrastructure. There are two different modes how you can use Kubernetes, the standard and autopilot one. Standard, I think, the most popular one, and basically you will see that on any project that uses Kubernetes. This is good balance between flexibility and convenience. And I think that we can go next, and I will try to explain how it looks in the cloud. If you have already working with Kubernetes, I believe you know the concept of control plane and nodes. And what we're talking about clouds, the control plane is abstracted from users. You don't have to deal with it. But actually, the process that run there is Kubernetes API server, resource controller, scheduler, storage, and so on. But what we are talking about the nodes, this is the virtual machines that compute engine ones that Google can provide for you. And what else? Here you can see the zonal cluster mode. By default, it is set up in a single zone. Control plane is in a single zone, and the nodes are also in here, in the same zone. But if you want more flexibility, you can go with multi-zonal cluster. Here, there's still one replica of control plane, but nodes are spread between several availability zones. But for high availability solutions, it is recommended to use regional clusters. Here, the control plane replicas are shared between the several availability zones, as well as the nodes. We can talk for more specific details later, and we'll try to discuss if we still have more time. What else I can mention? The features of standard mode is that control plane, cluster upgrades, repairs, and health check are taken care of Google Cloud. You don't have to deal with that. But you control node pools, auto-scaling, and more things that are related to nodes. Virtual machines are accessible over SSH. You can connect, do some stuff here. Of course, we also can discuss is it good practice or not, but people sometimes do that. Not even sometimes, I'm joking. And here you can use operating system of your choice that also give you more flexibility. Interesting statistics and some features that worth to mention, that for standard mode, you are limited to use 256 pods per node. You can choose between regional or zonal clusters, as I already mentioned. And you can run pods in any namespace, even kube system. Also, this is a good question, is it good pattern or anti-pattern to run everything in kube system? But you can do that as well. Also, some interesting facts that you're limited with 15,000 nodes per cluster, if you need such amount of them. And what else? Nodes per node pool, it's about 1,000. You don't have to memorize that, but just to know. If we're talking about maintenance of standard mode, you can choose the release channel. It means you can choose the Kubernetes version that you would like to deploy. Virtual machines are accessible for inspection, debugging, and investigation. And Google cares about automatic and manual grades. What I can say when you can use standard mode? If you want more flexibility and granular control over Kubernetes environment, which is also dedicated to controlling all the nodes. If you have specific requirements in your project, you have some customization and more or less predictable workloads. You cannot be 100% sure, but at least if you already aware of something, you can use that. Also, if you have the expertise to manage and optimize Kubernetes clusters or need to integrate with the existing infrastructure, this is a good choice for you. And as we already discovered, the most widely used mode, there is also one option that is called autopilot mode. It provides the simplicity of operations and gives you an abstract way of cluster configuration, so you don't have to deal with it at all. And little or even no maintenance is required. If you prefer a hands-off approach without diving deep into infrastructure, so autopilot will be good for you. If we're talking about maintenance, it looks like it's not required. Google managed that for you. And all the infrastructure, including virtual machines, are abstracted away and managed automatically. If we're talking about when to use that, if your project has limited or even no Kubernetes maintenance experience, if your workloads are highly variable or unpredictable, also a good choice. And this is also a good thing to optimize costs. So, as you wish, you can choose this mode. Here is the really huge schema, but this is a typical example of production usage of Kubernetes. I will cover some parts of that on the next slides, but basically what you can see here, usually you have the node pools. This is the virtual machines where your pods are deployed. And if you're talking about production, of course, more likely you will use database to store your data or some kind of storage, like container registry and so on. You will have to expose your application using load balancers, and I will also cover that on the next slides. If we're talking about exposing the service, by default, everything that is deployed to the cluster is internal and visible, not visible from outside the cluster. But if you need to expose your service externally, you can use solutions that Kubernetes provides. But we're talking about good opportunity to use cloud solutions. So these are ingress controller. When you create an ingress object, Google Cloud creates the Google Cloud HTTPS load balancer and configures it according to automation of ingress and everything objects, all the objects that are associated with them. Let's go to another part of the virtual machines. They are grouped like node groups, and of course you also can manage them. You can configure the auto-scaling of node groups. You can choose the types of the virtual machines. It is good practice to distinguish them by different kinds and types, depending on what kind of applications you're going to deploy, to save cost and optimize the resources that you use. And of course, it was to mention the storage. In terms of storage that Google Cloud provides as services, you can use persistent disks that are shared network drives. Also, it is possible to use local SSD storage that attached directly to the node if you need fast experiments with the cluster. Database are also considered like a storage, also managed by Google, like you use MySQL, Postgres, whatever. Cloud storage, also dedicated to buckets, if you want to store static data. And artifacts that the upgrade of container registry, which is called now artifact registry, you can also store your thing there. And I would like to finish the discovering of Kubernetes clusters by the overall features. Google provides flexible node upgrade strategies. Also, you can use built-in login in monitoring and don't care about using the external services for that. It is integrated with CI/CD options like Cloud Build and Cloud Deploy, and you can also use them. Built-in security measures are also the option, and cluster scales automatically. So these are really good things to deal with Kubernetes in GCP. But sometimes this is not ideal for you, and Google offers something else. And here we go into Google Cloud Run. What if you don't require container orchestration at all? Maybe you don't have experience or want to deal something in the simplest way. You don't have to provision the nodes, care about everything, so Google Cloud Run is the good option for you. This is fully managed service for stateless applications. So this is serverless platform for stateless containerized services, and they mostly use with events-based like web subs or Lambda functions. Benefits of using Cloud Run here on the slide. This is easy deployment of microservices with a single command. It scales automatically based on the number of incoming requests and scales to 0 if there are no requests at all. And it supports for code written in any language. So, as I already said, it is recommended for stateless application, events-driven, and can make your things better without diving deep into orchestration of the clusters. So, everything was good, but what if your company needs to control multiple clusters? You probably have a hybrid environment, or you adopt Azure, AWS, something on premises, on bare metal, and you need to manage all that stuff. Maybe you need to deploy in different cloud, or maybe you just use on premises. Here is a decision for you. This is Google Antos, which is also called GK Enterprise. This is the basic overview, and Antos clusters are extensions of Google Kubernetes engine for use on premises environment. Here you can see on the schema on-prem, AWS, Azure, and whatever. And Antos capabilities are built around the fleet of clusters. So this is the main word describing it, logical grouping of Kubernetes clusters together. And what I can say, when it is recommended, for enterprises with multi-cloud or multi-clouds, hybrid cloud strategies, complex security and compliance needs, and focus on application modernization. Antos manage traffic, authentification, and access control, security, and compliance policies across your fleet. So this might be a good decision if you really have complex, large enterprise environment. And I wanted to finish this presentation with questions for you, but I would like to summarize and say that despite the fact that cloud provides really great opportunities to adopt their services, and they can manage everything besides instead of you. Everything is automated, everything is good, you just pay money and don't care, but in real world, there are no good examples. Actually, I have only 2 examples of great projects where everything was set up in the cloud, and it worked. But unfortunately, sometimes I do really bad things, like SSH to cluster, doing something manual work and so on. But this is really good, and I wish I can get some examples from you. And also my latest question is, has anybody tried Antos or Cloud Run? Because I've not, but I try to share that these opportunities are available. So thank you for your attention, and ready for your questions.
Thank you, Veronica. I actually have a question that's probably going to be directed at you and Kiryl at the same time. So you mentioned that it's possible to provision a local SSD on the Google Kubernetes cluster in a standard mode and maybe not a pilot mode, I'm not sure. Are there any limitations on the type of VMs where you can attach this local SSD on Google?
As far as this I'm aware of, there are no limitations. You can attach it to any node in your cluster and you are good to go.
Kiryl, what can we say about AWS?
So yeah, it's not so simple on AWS because probably a lot of you heard about instance storage for EC2, But actually, this instant storage, first of all, is available on machines, on specialized machines, compute-intensive, data-intensive, or on metal machines. And on low tiers of such machines, there are no SSDs, there are HDDs. So it's probably not the performance you expect. And only on high tiers machine you can have local disk of SSD type. And storage is, are there any restrictions on storage on Google Kubernetes?
I'm afraid I cannot fully answer these questions. They are, but I need to memorize something. Maybe we can discuss it after the presentation.
I was asking because actually on EC2 is not so big. It's around 960 gigabytes for SSDs. For HDDs a little bit more, but yeah, it's not so flexible. You might have multiple instances to satisfy your workflow.
I think in Azure there is a dependency on the machine sizes and families. Okay, and maybe guys you know more about it, but from what I've read, it's kind of similar to what you said. The bigger machine,
feature,
and also the disk depending on the size of the machine, and it could provide different stuff. I mean, throughput, I/O, and other things. So.
Well, that's only fair because you have a physical machine and a single disk, and there can be like 1 VM or 10 VMs. So you got to
Well, when people talk about clouds, they think this is something like abstract, especially that are not from IT world. They think that somebody on heaven provides them clouds, but this is about physical data centers.
Yeah, let's recall this famous phrase that there is some machine that running your cloud code somewhere. Let's not forget that. Okay. Anyway, any questions from the audience? Oh, okay, we see a couple hands.
I believe we're talking about modern IAM roles.
I think it's about troubleshooting, maybe just to understand what is going
to
on.
To access the stack driver that is for logging, that stands for logging in Google Cloud.
I can try to answer to this question in one sentence. You have to implement decent observability in general on all levels. If you have decent observability, you know where's the issue, what is the reason, and a decent observability, I mean at least logs gathering, logs analytics, tracing. If you have everything in place and you have alerts on top of it, and you can probably have multi-layer health check or real user monitoring, you definitely will understand if something is wrong with your system. It's not directly related to Google or AWS or any other cloud. It's not specific. It can be done in bare metal. You have to have observability in place.
Well, observability is kind of there. We just don't have right setup of
Start
accesses.
from the first step. Start gathering logs. Set up a first alert. Do it.
I believe that not everyone should be able to access logs. Maybe the person who is responsible for doing something with that. But anyway, you can read the logs, but if you don't understand what to do, maybe it's just useless. This is what I mean.
In our case, is a problem that person who can read the log and person who understands what they mean is different person.
I'm so sorry to hear that.
It's quite common though.
Yeah, it's quite common, yeah. I was waiting if somebody can ask that. Basically, these clouds, they are competitive and they try to implement everything so fastly, so they provision services really fast. If one cloud provisions something, another one will, couple of months, and they will expose it as well. But from my experience and my story, the first time when I tried to use Kubernetes, it was 2018. And I already tried this as a managed service by Google Cloud. And correct me if I'm wrong, but for that time, this was only the one cloud that provided you managed Kubernetes service. And I started to adopt that, and I found that it's really easy to start. It provides you G-Cloud console. You don't have to install additional tools. And if you don't understand anything, you can just try simple commands and you see that it works without configuring the local infrastructure to deal with that. And it's been a while. I used to work mostly with AWS, and now I'm again back to Google Cloud. And you know what? Nothing has changed slightly, and I can say that I don't mean that it's bad, that nothing changed. I mean that it's still easy to use, easy to set up. You don't have to care much about setting some local commands and so on. And it's, it's really looks like native. It's something that it's really easy to use, easy to start, and you think that everything works like as it should be. And I think that for me, it is more easier to use. And also today we discussed when drinking coffee with our guys, the ingress controller. As I remember, the Google Cloud, they provided ingress control really fast. And there were several years where there were no such control in Amazon. We have to use Nginx, Traffic, something like that. And when Amazon implemented this ingress LB controller, it was horrible. I didn't understand how it works. Yeah, and now I'm also working with Google Cloud. It's just easy to adopt and easy to set up. And I can say that if I had to choose, I would go with Google Cloud.
Correct me if I'm wrong, but I think Amazon in general doesn't love developers too much, right?
Probably yes, but there is now something ideal. That's why companies can go with multi-cloud setup. They store something in one cloud, something in another cloud, and it works somehow. Yeah. Yes, there are limitations, but I cannot give you numbers. I'm sorry, but I cannot keep everything in my head. But I can memorize that and maybe answer you later. And yep, you can use GPU. Probably I not fully understand the question, but it looks like it's the same.
Yeah, I can answer from AWS perspective. So recently, literally 10 days ago, they announced extended support for old Kubernetes version. It's going to be paid. Prices are not announced yet, and extended support is available for a period of 1 year.
It's one of the most popular things about OpenShift, the extended update support. And you can stay longer on the same version. Yeah, absolutely. Good. Let's be honest. Most of our customers suck at lifecycle management, and for their own stuff, but also for the stuff they consume. It's a pain, yes, absolutely. But most of the clouds do have. What varies is the duration. Yeah. So some have 18 months, some have 12 months. It's been a while since I checked with Google. I don't know for the top of my head.
It's the pain, especially in the parade process.
Yeah, I completely agree.
I didn't say hi everyone. Thank you for coming. Really appreciate to see you here and really to be here, by the way. Thank you on the spot, guys. This topic is about connectivity and networking in Azure, and I would really appreciate if you can jump and tell I did it and it should be, improved, or please don't talk about it, something like that. Just a kind of conversation would be great. So, press on the number, this one. First of all, I don't know about level of your experience with Azure, right? Especially in network domain, but I assume we can. I'm also not very good in that area. Yeah, I'm still learning. Yeah, so that's very good. Our agenda. Yeah, it is designed to shed light on these three topics. First of all, we'll try to talk about the global infrastructure stuff. Next one, as you can see, it's about network services overview, and we will finish with some, I believe, interesting global statistics. Yeah, about top 3 cloud providers. So this is a kind of schema, right? How it is represented in a structural view. So from geography to the region to the availability zones and to data centers, from the top to the bottom. And what is the top level of this structure? Top level of this structure is Azure geography. This kind of thing is for customers mostly, for guys who are trying to buy the offerings from Azure. This is a kind of discrete market which consists of one plus at least one region, I would say. Yeah, and also the goal of the Azure geography is to provide the requirements for compliance, right, and for residents of the infrastructure. That's the point. Here you can I inserted the my current project available geographies. There are not a lot of them, but many. So I assume, as far as I remember, each subscription is able to. They have a different set of geographies. Yeah, actually. So moving on, we're talking about regions. By the way, what I wanted to highlight, there is a kind of difference between our clouds in terminology, right? Geography. So I assume when I'm talking with guys from Azure, they understand what I'm talking about. So for example, when I heard about the organizations from Kiryl, I tried to map this thing to Azure, yeah, and I believe it is the subscription there. I can't be mistaken, but if you guys wanted to say something, this is the time. Okay, regions. Regions, they are the next level after the geography. They are, if we're talking about the geography, it is the, can be US, just US, right? There you can go a bit to the bottom to see what kind of regions we have there, and they could be US West, US East, US East 2, and so on and so forth. Regions are consisted of availability zones. The very important point from Azure, they are recently reached the quite huge milestones for them, based on the CTO awards. Each region now equipped by availability zones. That's very cool, because previously they didn't do that. Okay, for now we have, as I said before, 60 plus regions available, 300 plus data centers inside of the regions. As for me, it's very huge. I don't know, guys, do you have such statistics about the clouds? Just approximately.
About the data centers, it's always kind of sensitive information where they're located physically, and yeah, I don't know how many of them are used by AWS Cloud.
Regarding regions, it wasn't 74, I guess. So they have more. Both Google and Amazon have more regions.
Okay, nice. Not very nice, but okay. Yeah. By the way, okay. Yeah.
No, sorry. Okay. Yeah, we are better.
Okay. There is one interesting thing here. You see the QR code. This is actually this map. Yeah. You can find this map by scanning that QR code. This map is interactive. You can explore the Azure Global Infrastructure by like kind of game. See the geographies, regions coming soon, and so on and so forth there, and connection between them. That's very interesting to see. Another one point, quite quick, Poland region, good enough. You can see that there are a lot of interesting customers who are using the capabilities of that region. I believe the interesting point for me is Zhuravsky. It was. I think, yeah, I think they are nano-Zhuravskys. They are using something from cloud, but I have never used nano-Zhuravskys. Okay. Availability zones. This is the next level of that structure, and this is a point of redundancy and high availability of the Azure region, right? In each region, we have three, at least, I don't remember exactly, but let's say 3 availability zones. They are not very far from one from each other, yeah, and but they are not close, right? So the main point from networking perspective what is the good that the connection between those availability zones is quite huge, and the latency based on the statistics and words of the CTO is not higher than 2 milliseconds. This is kind of standard for all the availability zones. And I propose you to move on to the networking services and basics of the Azure networking. And I just like to highlight some connectivity stuff, based on this schema. What we're talking about here. From the top to the bottom, there is a kind of network traffic flow, how the traffic is going into the Azure global network and reaching the data centers. The first point of entrance, it is the express road, not the express road, edge zone, which could be connected to the public internet, right? Or from the other side, it could be connected to some enterprises via network service. The first one, which I mentioned, express road, good. And after that, it is going, traffic is going inside to the Microsoft global network, global backbone, and AK, and so on and so forth. So as far as I remember, there is a interesting network routing method, which Microsoft uses to route traffic within the backbone. It is called like cold potato routing. Have you ever heard about it? Hot potato routing? Okay, hot potato. So you can understand, this is the opposite side of hot potato routing. It means that traffic, which is going to the Microsoft network, it stays as long as possible there to be inside of the network, and this will be a mention about it at the end of these slides. So when the traffic is going down to the regional gateways, by the way, this is an entity. I didn't find the explanation of what is it exactly, but it is what Mark Rusinovich told about it, the guy who is CTO of Azure. He told that regional gateways provides the massive interconnectivity for availability zones within the regions. And it's also a kind of redundancy thing, because on physical level, this is a duplication of all the devices and cables and fibers and so on. So this step is quite huge in terms of region redundancy. And the last point is data centers within the availability zones. What I can say about data centers? So they have a lot of fiber there, first of all, and they're using the approach of oversubscribing their network. It means that they provide, they have an infrastructure for data center, but they propose more, they sell more capabilities that they can process in one moment. This is just to trying to save costs, because the idea that there is a minimal 0.0001% that everyone who are using that network will use it in the same time. That's why they're oversubscribing their network. Okay, sorry for that. Moving on. Okay, let's talk a bit about Azure services. They're logically categorized by those labels. It's just trying to keep in mind, not to remember all of them. Anyway, the categories you see, two of them are related to application, to working with application, about their delivery into the Azure, and protection within the Azure. Monitoring, it's understandable. You can monitor network from different perspectives in different, let's say, parts on the Azure, on-premise sector, and so on. And connectivity, it's most common category, which includes the virtual network, for example, or, as I know, VPC, right, in AWS, or not. you can punch.
Yeah, basic networking construct in AWS is VPC network, and yeah, it's kind of related to things that you just described.
Yeah. Okay, this is a bit more with examples of those services, but to be honest, I don't want to spend a lot of time here just reading from the board, load balancer, private link, and so on. Let's move on. The reason why I will try to go on is just to speak about something more concrete, right? And this example is the piece of architectural design, the sample from the Microsoft architectural website. It is in scope of Azure, right? And we will talk about multi-regional load balancing. This is the whole schema. The idea is to show how the public-facing application could be deployed into Azure and balanced across the regions and across the availability zones with specific services. So, yeah, we will try to start from the left to right. Yeah, the left side will be this one. You got the point, right? Okay. This is the entry of our schema. Yeah, and what is going on here? The browser, the end user is sending requests to some endpoint. In this case, publicly available endpoint would be Traffic Manager, which has the how it's called, DNS name, right? Sorry, DNS name. It has DNS name, and using that DNS name, we can reach the application which we want to try to reach. Yeah, but this is not a target endpoint. Before that will be the Traffic Manager, which will use the routing mechanism inside of this resource to balance the traffic across the regions, right? And at the right side of that, we can see that we have two regions, West US and East US, and they are globally peered by the global VNet peering, which is also the way how to connect regions and organize the cross-regional replication and so on and so forth. Okay, a couple of things about routing mechanisms within the Traffic Manager. Have you worked, guys, with Traffic Manager in your project? Really? Is it so?
Is it load balancer or?
It's a kind of DNS-based routing balancer. It is not the traffic. It is not going through the Traffic Manager. Traffic Manager just analyzing the incoming traffic, yeah, and based on the list of endpoints which it has in the profile, it is balancing. Again, based on the routing methods which you use, it is balanced to the right endpoint which is applicable in this case. Traffic is not going through the Traffic Manager. It is not terminated there. When Traffic Manager decides which endpoint you should use as an end user, it provides that endpoint to you with IP address, and your connection will go to that IP address directly.
So it's a fancy DNS, simplified.
I think yes.
Yeah. So in AWS, all of this managed by Route 53 service, which allows you to resolve DNS and also perform weighted routing.
Yes. I read about it.
If someone of you used Route 53, you can also raise your hands, and yeah, I believe it will be related.
Okay. No one using Traffic Manager.
Come on, you're like somehow make your website reachable from the internet, right?
Maybe you're using front door, right? Okay, that's better. Okay, so Traffic Manager routing mechanism. I would provide examples of two, I think. You can prioritize traffic by the priority of your endpoints. You can just mark the first one endpoint as the main one, and all the traffic will go there until it will be unavailable. The second would be the next one if the first one will be, will crash. This another one routing method which I can remember, it is based on the performance of endpoints, and mostly user which has the smallest latency, I would say the lowest latency to the endpoint in the list will connect to that endpoint. Yeah, move on. the middle of the schema. It is the when the traffic is reached the Azure through the balancing of traffic manager. By the way, I'm showing here the only one region because another one will be mirrored. And here Microsoft provides proposed to use double inspection schema with Azure App Gateway and with Web Access Firewall and Azure Firewall in the consecutive sequence, in a sequence, let's say. So first one, App Gateway and Azure Firewall, they are available across 3 availability zones, which is also about high availability, and they are the thing for which I like App Gateway. It is the because it can do a lot of stuff like SSL offloading. It can provide a lot of rules for routing and rewriting traffic within the service, because it is terminating the traffic, yeah, and it can do a lot of stuff within. And it is also a level 7 load balancer, okay. And Azure Firewall, double inspection, which is very good. Why it is good, you can read on Microsoft architectural website. Okay. Moving to the last part. The last part, it is repeatable part. When your traffic is inspected twice, the traffic goes to the load balancer on the 4th level, and which is available across 3 availability zones, and it is traffic is going to the 3 endpoints, which are virtual machines here. They're also provisioned in 3 availability zones. This is a kind of summary. Layer protection is a good thing. Please read it. And again, about the availability, all stuff which we talked about, this is a good, right? You need to protect your application in any way. Fancy stats, the last part. And I have 29 seconds to do it. There is a Southern Eyes company, third-party company, which is a part of Cisco now. They are providing a report which contains a lot of comparison between top 3 cloud providers in terms of connectivity and architectural designs. And there's quite interesting to read about it. It is publicly available, but you need to provide your working email to download it. Yeah. Okay. First one, starting from Azure. This is just a screenshot from that report. What is it about? This is showing us the traffic which originates from the New Delhi in India and trying to reach the California. So between two locations, traffic, right? So blue dots are representing the traffic which is out of cloud provider network. The green dots representing the traffic which is in cloud provider network. For Azure, traffic is reaching the Microsoft network in New Delhi. You see this. The start of in New Delhi. Sorry, maybe I can do it. But anyway, on the left side there is a New Delhi. Okay, there is a New Delhi here. And here we have the entrance into the Microsoft network. Again in New Delhi. And it is going through the multiple hops, mostly without interruptions to California. And this is about cold potato stuff. Google, same story, even better. And no offense. Guys, I'm sorry. No offense. But this is just like a small thing where AWS is not good comparing with other. You need to read the report. Please do that. So yeah, you see that New Delhi, and other stuff, and so on. And here we have the entrance into the AWS backbone on California. But I just want to say that AWS doesn't, doesn't talk about it like this is, oh my God, Azure is better, Google is better. No, they're just using the publicly available roads to do that. This is the politics of them. And they provide, I think they provide the...
for those that to use basically same architecture of networking as was demonstrated for GCP and Azure, you have to enable CloudFront. So only CloudFront allows you to use this potato method. Without it, it's going to look like this.
Yeah. So it's just the statistics, which could be interesting, I think. That's it. Thank you very much.
So on the last fancy stance, I feel like I kind of need to defend AWS here because AWS actually has a service that's called Global Accelerator, right? Yeah. Yeah, and there are two very important bits about it, right? So the first bit is that your traffic will enter the AWS backbone or whatever you call it at the closest point of presence, right? But the second very important bit is that the endpoints on the Global Accelerator actually terminate TCP connections. And the rumors are there is a reason for that. I mean, we can discuss this. I'm not really sure if that makes sense, although it does. So for example, you can disable TCP slow start to reach your actual cloud services faster and so on and so forth. But the question is, it's really great to see that in Azure, you get the thing essentially for free, right? You jump into the backbone, you're there. But is there any analogy of Global Accelerator?
Yeah, front door. Could do the same stuff. It is, I think we're talking about something called CDN, right?
Global Accelerator is actually separate. It doesn't have to be a CDN. I believe the CDN infrastructure, accelerated buckets, and whatnot.
Because you mentioned that it could terminate on points of presence, right?
It does terminate. Yes.
Yeah, and front door do the same. It terminates, but it's categorized as CDN. That's why I'm talking about it. Okay. Yeah, but again, this is about it.
Of course.
Yeah.
Of course. Okay. You guys have any questions about networking?
Yeah, I actually have one. So,
the question was, you demonstrated two flavors of firewalls, and one was called like WAF, Web Application Firewall, I believe. Yeah, and the second was just firewall. What is the difference?
The good question, by the way. That's okay. So first one, web application firewall. It is working good and only works with web applications which are published, right? But to internet, you also could have the applications which are running somewhere without access to internet, right? And Azure Firewall would be the better choice for such applications. Why that schema is used in both? That's a good question, again. So from what I've read, right, Microsoft suggested to use that solution because of one important thing which is doable by Azure Firewall, which increased the whole security. And I don't remember what is it. That's, yeah.
Will I be correct if I assume that these two different firewalls are working on a different OSI level?
Yeah, so definitely, yeah.
Web application level.
Yeah, because I mentioned
that.
That's
other firewalls level 4.
Yeah, but I mentioned.
The difference.
No, that was another one story. But
okay.
Yeah.
Gotcha. Thank you.
Two letters, ID, blah blah. I don't remember what.
Okay. Fair enough.
Yeah.
Okay, maybe we have some questions from the audience.
Okay, I can. It depends. Again, it depends on your experience and mine. What I had, I really saw teams which worked perfectly, very smooth, very how to say, any stream, any meeting with I don't know 80 plus, 100 plus people was very cool, no interruptions and so on. It was when I worked at TPAM. Yeah, and then I went to another workplace. It is how they are called. They asked me to call them Swiss Investment Bank, but don't say the name. And they quite recently introduced Teams there, and it is nightmare. It's this their previous product, Sky for Business, was brilliant comparing to the Teams. And when I started working there, I saw that why are you using Sky for Business? It is like 300 years ago, like Gandalf. It was a long time ago. Anyway, it depends on what network guys working there. That's and okay. Every answer could be that. But yeah, I think I don't know the right answer, but it's quite related to the experience of the guys who are working on it, and a lot of dependencies. Again, that's my answer. Yeah, they are. You can, if you were fast and scan that QR code, you can. Anyway, you can find that interactive map. Just type in the global infrastructure, Azure global infrastructure, and you can scan it and see the map how edge zones they are presented. It's just a visualization, and they're not given some light there, but of course they have availability edge zones, and how they are presented. I mean, their structure, the physical stuff which is constructed there, could be different. It could be like a cellular stuff, not the cellular. What is the? Okay,
cellular towers,
yeah, that's one. And you can see the quite autonomic modules, like I don't know how to say, like a storage, just simple storage somewhere in the middle of Warsaw, with the square of 2 meters on 3 meters. But again, not such poor one. Yeah, it is very expensive stuff there. So yeah, they are presented everywhere, and as every cloud here, they are going to increase the how to say, the square of presence. Yeah, the amount of those points across the world. This is just speed of business for every cloud. That's how it look like. Thank you. No questions.
Okay. Thank you very much.